have a great round of speakers that made us event go sold out really fast. And the next reason, especially for me, is that it's the very first SFDUG event at the Bagot. So thank you for coming and making the effort for a new venue. So today, for the educational module, we have Tobias Hathorn from Autodesk and a very last-minute presenter, which we're very, very happy to have, Josh Goldstein from Autodesk. They're going to talk to us about Dynamo and FormIT and how to create computational workflows and integrate that with Revit. And after that, we have Bihan, who has been working with Because We Can, and she's going to present to us the usage of Dynamo and C# and potentially Microsoft Visual Studio and a lot of interesting stuff. So without further ado, I let Caesar explain more about the new interesting stuff that's happening.
Yeah, so the committee touched base with the AIA last week, and we talked with Stacy Williams, and she was really open to collaborate with the group as far as marketing and hosting events at the AIA. So we're happy to announce that we have now established a close relationship with them, and our events are going to start getting marketed by the AIA, and that's going to reach out to a base of about 7,000 people in the Bay Area. So hopefully this meeting grow up inside. Put it more on the spotlight. And so also that opened up the AIA as a potential place to go to these meetings in case there isn't any firm that's open to host it. So we're very happy to start that starting in February. All right. Another announcement is that the group is going to host our first workshop, and this is going to be a 6-hour hands-on training on design script. And it's going to be taught by us, the committee, the last Saturday of April. The venue is still to be determined. It might be the AIA or it might be another place. But stay tuned for that. I know there's a lot of interest about learning how to use Dynamo script and integrating it in Dynamo. So our next meeting is potentially going to be at the AIA. And our next presenter is Brett Young with MEP, talking about Dynamo and Clash MEP integrations. And one more announcement. We are looking for a volunteer to help us with the campaigns. So if one of you is interested, it only takes about 4 hours per month. And there is 6 of us in the committee. We meet online once a month. If any of you are interested, just let me know. Our email is there, and as usual, we're always looking for speakers. Okay, let me introduce Tobias Hathorn. He is on the line with Josh Holstein. They are product managers for FormIT, and they work in Autodesk based in Colorado. Tobias, welcome. You have in the room about 20 people, 25 people, and I'll make you the presenter.
Sounds good. And yeah, sorry to be presenting remotely. I wish I was there in San Francisco. It'd be much more fun. But if there's ever a part in the presentation that you want to interrupt and kind of ask more questions, get more details, have a conversation about, please have Cesar sort of moderate that, and we're happy to kind of stop and chat as we go. I host a Revit user group here in Colorado, and we do a roundtable style, so it ends up being a lot of talking and not as much presentation. So feel free to interrupt anytime. And yeah, I'm really fortunate Josh is able to stick around tonight in Colorado and present this with me. We're both on the FormIT team here in Boulder, Colorado, and we've been working on the Dynamo integration in FormIT for about a year. So he is very knowledgeable and very skilled and can answer a lot of questions too. Just to kind of set the stage about what we're talking about, this blog post is on the Dynamo website. It came out about a year ago or so, 2015. And that was when Dynamo Studio introduced this concept of a customizer. And the customizers are pretty cool in that they're standalone Dynamo scripts that you can build in Dynamo Studio and essentially publish to the web. And that's what the second image is showing, is a really simple browser-based input-only interface where you have a chance to adjust the inputs for your graph and have it compute through the cloud rather than through the Dynamo installed core. So it's very portable. You can basically share this URL with anybody and they can start to access the graph. Also, your phone can access those graphs, so you can start showing things off to people from your Safari web browser on your iPhone. And there's a variety of sort of rules about the customizers, but in general, that's kind of the same entry point that FormIT has for the customizers. So I'll kind of illustrate what the customizer is, and then we can show how it plugs into FormIT, and also talk a little bit about what FormIT is all about. Maybe you guys have heard of it, maybe you haven't. So this is Dynamo Studio, and this is a pretty cool graph that we worked with one-to-one architecture in, I think they're in New Orleans, Louisiana, to create this graph. And it's a relatively simple set of inputs: length, height, tower width, and then a variety of options with those, running through, basically pushing and pulling the points of this mass geometry, and then in the end, outputting solid. So one solid for the top volume and one solid for the bottom volume. And like I said, it's relatively simple, but it does have this handful of parameters. So the method for getting this to share is through the file menu. There's an option to send to web, and that's pretty much the key. When you click that, it will give you a chance to name it. I already have one created, but I'll make another one, SFDUG 2, and you can put a description in there. Nobody really puts a description in there, but if you wanted to, you could, especially if you had multiple variations or versions, might be helpful. And you essentially hit publish, and in a few seconds, it pops up this URL, and you can click to visit the web and see this thing in action. So I'll jump back here to the graph real fast and just show the tower location parameter. It's a really easy one because you can see the tower move along the base. So I'll adjust that one to 0.9, and it slides across the base. Come back over here to the web browser interface and find the same parameter, tower location, and slide that over, and you can see it update too. So it essentially follows the same rules, except that now it's untethered from your desktop. So using Dynamo in the cloud, you're able to recompute a graph very quickly. And that whole thing is pretty cool. And like I said, that's how you can basically get the same graph into FormIT. Over here on the right is my Dynamo panel, and I can see a list of all these sort of scripts that I have access to. And this is the example SFDUG, where I can just click it and essentially recompute that graph from the cloud and then pull it into my model. And this is, just kind of showing that one standalone. I'll delete it and then show you why FormIT is useful, can really benefit from this. FormIT is a sketch modeler, so it's a push-pull, very fast, fluid modeling environment intended for architects. So in the background, you can see this Google Maps image for context. We were able to build up the surrounding downtown area very quickly, and then you can drop your mapping building into the site. So that's the story with this graph. if you double-click it, it's grouped right now. So if I double-click it to go inside the group, the same list of parameters are available here as in the Dynamo Studio environment and as in the Dynamo Web environment. So I'll find that tower location parameter and again just run that slider, and what it'll do is kind of wait to see if I had any other changes. It'll recompute using the cloud and then send me back the updated geometry. So again, I could pull that location over and we'll spend more time waiting for the input than it will actually recomputing the information. So just in a nutshell, that's how Dynamo plugs into FormIT. Graphs that you created in Studio can be published to the web, and then from the web, you're able to link those into your FormIT sketch. And I'll show you lots more cool examples. And Josh has a lot of other pretty great stuff, because it doesn't have to be just for massing level buildings. It can also be for building components like stairs, movers, grids, things like that. So I'll just kind of pause for a minute. Any questions about that before I show some more stuff?
I believe that FormIT was free last time that I checked, but do you need to subscribe to like A360 to publish this to the cloud, or how does that get into FormIT?
Yeah, I'm pretty sure I got the question, and it's basically how do I get FormIT, and is FormIT free, and what's the scoop there? This is our website, and I was headed here next anyway, so it's great. We've got a free or pro button here, and it'll pull you down to this part of the page where it talks about FormIT 360 Pro. And with the Pro subscription, which is the same cost as Dynamo Studio, I think it's like $30 a month, you get FormIT for Windows, and inside the FormIT for Windows app is the Dynamo piece. Also with FormIT Pro, you get real-time collaboration, energy analysis, solar analysis, and Autodesk materials. So sort of the full gamut of the app is yours for about $300 a year. And otherwise, FormIT is free when you use FormIT Web and FormIT on iPad and FormIT on Android. All of those are free. And they don't have all of these pro features built into them, but you can still turn on those pro features in iOS and web by becoming a pro subscriber. So pro means a couple of things, but the biggest advantage is FormIT for Windows. And that's what I was showing right over here. The UI for Dynamo is here in FormIT for Windows, and the solar analysis feature is here in FormIT for Windows. Let me actually jump out of that, go into monotone mode, my favorite visual style in a FormIT, and then show you solar analysis real fast. I'll double-click those volumes and then do a quick analysis in Canvas. This is cool because as you hover there, it'll give you some information about how much solar gain you're getting on that surface, how many BTUs, and you can calculate this and then change it for which month. So if you're most interested in, say, October, you can see those effects. And, in March, these are the effects. It's just really fast and fluid to update that. Other questions?
Hey, Tobias, how do you load the Dynamo definition into FormIT? Web.
Good question. Yeah, so they're all tied to your A360 account. So in Dynamo Studio, before I publish, I'm logged in as myself. And when I hit send to web, it basically it associates that published Dynamo graph with my A360 account. So if I come back over here, I don't know if it shows me that I'm logged in here, but this configure manage, if I click manage, this is going to show me the different graphs that I have access to with my A360 account. I don't know if there's an interesting one to show you. but that list, that same list in the Manage tab, is the same list that appears in FormIT. So when I come back over here, look at my Dynamo page, these are the ones that I have access to. So it's stuff that I've published, and Josh will show you when you click this plus button, you can actually link to a URL of something that somebody else has published. And that is pretty sweet. Let me show you this example over here. Yeah, so Ryan Cameron is a buddy. I follow him on Twitter, and I saw that he was working on this neat, thin design layout in Dynamo Studio, and he published that graph so other people could kind of check it out. So he shared it with Ian and Kyle and John, and so I saw that and grabbed it, and also took my spin on it, basically opening up his wall design in the web, linking it into my FormIT session, and doing some solar analysis with that same layout. So it's very shareable, very accessible. So I'll jump back over here to the website, the FormIT website. This building in the back is something Josh built. Pretty amazing. Great graphics like SketchUp, solar analysis, like SketchUp has never had, and also these great black and white monotone modes. I really love those. If you click this watch video button, this is kind of our example video of using that creased tower that I was just showing. These guys one-to-one basically built this out for us with a real site, a real project, and it shows kind of how far they went with it, that it wasn't just the massing. They started to elaborate that building with direct modeling, push-pull, and editing it in the iPad app, and then going a lot further with it too. This is the Windows app and solar analysis, but they also pushed it all the way into Revit and started doing the curtain system by phase and the more elaborate facade, and I mean, just doing a ton of stuff. So this video is a great description of sort of the workflow and the lifespan of a sketch model, that you don't just have to throw it away as soon as you're done with the design phase. You get to keep going with it on into Revit. So that's up there on the website. And just to give them credit, they've got the FormIT project that they did on their website. These guys are great. Awesome, stylish, contemporary architecture. I really love it. I want to give another quick shout out to Mike Engel. This is a FormIT customer who's been really pushing a bunch of things. He does a lot of hotel design with his firm, ESG Architects. And so he's been building out a hotel configurator, basically the hallway width and the number of rooms stacked on either side, how many stair towers and the distance to the stair towers. He's basically got this hotel formula, and then dragging that, dropping it into FormIT, exercising the parameters, come up with unexpected layouts. And he's been using Project Fractal a little bit. I'll touch on that at the end. Hopefully we'll have a few minutes. I can talk more about Fractal. But this it basically generates a variety of options off of that same Dynamo script. So basically, the time invested in authoring the Dynamo script pays a lot of dividends getting into generative design. It's another pretty sweet example. I believe this is Ian, but I'm not 100% sure. He basically built out Calatrava's World Trade Center Oculus using Dynamo Studio, and then shared the Dynamo script. And he was pretty onto the web browser aspect of it, so he put the link in here for the customizer, and that's essentially this guy here. So it's not just that simple matching. It can be a pretty elaborate Dynamo script as well. you can adjust the fin count and a bunch of the parameters that I assume Color Travel is working with too. I'm not really sure. And I'll go ahead and open up the FormIT version of this file too. It's pretty cool. Yeah, so I mean, I can't even imagine trying to model this in a sketch way. I just don't think you would really do that. So the idea of Dynamo plugging into FormIT really gives FormIT a little bit of parametric underpinning, which we all know how important that is. And the last thing I want to share before passing it over to Josh is this example from MT Hogard. And Jesper created basically a parking garage configurator. So much like Mike with his hotel configurator, basically building out the bays and the height of the parking garage so you could study a variety of options pretty quickly in context with a site plan and other things in the background. I really love that example because even though parking garages are a pain in the neck, they do drive a lot of architecture. So taking the rudimentary and routine pieces out of it, giving that to Dynamo, I think is a really great idea. So, any questions while we pass the presenter over to Josh?
Not here. Go ahead, Josh.
All right. Hey, everybody. It's an honor to be here remotely with you tonight. I've been working on some building elements in Dynamo and FormIT, and I've exported a couple of those. So this image that I'm showing here, almost everything that you see was done in Dynamo, building elements. So the V-shaped trusses, the randomized panels, the storefront systems, all that stuff I made in Dynamo and then dropped in FormIT, and that really made the process of getting this building built way easier than doing everything by hand. So I'm going to show you some of those things and how I drop them in and how I sort of filter through them. So in FormIT, we have a nice filter mechanism, and so I want to drop in a louver generator that I made. Who doesn't love louvers, right? So I made a lot of versions of these scripts, and you can see in my list here when I don't have it filtered, I have a whole lot of Dynamo scripts going on. And so we've
I think we lost the audio. Hey, Tobias, if you're next to Josh, can you tell him we are not hearing his audio?
So we lost his audio. Let's see. Can he just keep talking on my phone and we can put it in speaker? Alright, you're on speaker. Hi. You have to speak a lot louder.
Okay.
Better.
Is that better?
Much louder. Having technical difficulties.
Yeah, they say I need to speak much louder.
That's better,
Okay.
thank you.
Can you share your
I see.
desktop?
Yeah, let me pull up the WebEx. Hold on one sec. Share my desktop. Yep. Cool. Hey, sorry about that. No live demos complete without some audio issues. Okay, can you guys see my screen?
Yes.
Yeah, all right, awesome. So I was just going to run through sort of how I use these scripts in context. So I have a fictional building here, and you can see I've got the storefront systems kind of attached to the building, and I've got some columns, and I've got some stairs in there. What I'm going to do is I'm going to place my latest louver generator, and I want to put those louvers on the side of the building there that doesn't have any mullions. So I place the louvers from the panel, and the way that this works is these are this louver system is actually inside of a FormIT group. So as such, I can do things with this group that I would be able to do with any other FormIT group, like rotate, scale, paint with material. So I'm going to rotate this guy around, and I'm going to just kind of grab it and place it on this facade, and I happen to know the dimensions that I need. So what I've done with this script is I have it generated based on overall height and overall length. So I know that I need this thing to be about 55.5 feet tall and 150.5 feet wide. And I'm going to let Dynamo in the cloud chew on that. And when it comes back, I should have a louver system that is as tall and as wide as I need it to be. So there it is. You'll notice that because I'm inside of the group, as I'm hovering over the louvers themselves, I get highlights of the edges. And so what I can do is I can exit the group, and now I can grab that entire group and move it over. And now I've got those louvers on the building. Another cool thing, because we're using FormIT groups, is in our next release, we're going to have hiding of everything around the group, so all the context can go away. So I'm going to hit H, and I just hid everything outside of this group, and I'm able to just sort of isolate exactly what I'm adjusting with these parameters. So that's pretty cool. And then unique versions. So I placed this louver system once, and I can basically duplicate this louver system by doing a control move. And, sorry, lost my earbuds. So I've got a new version, a new copy of the louver system, but it's not unique. So if I change something in here, like if I change the overall length to be a lot shorter, like 100 feet, you'll notice that both of them will update at the same time because they are linked together. But what's nice is because of the way FormIT groups work, I can actually make that group unique and avoid that in the future. So now I've got these two that are sort of different. I'm going to take this one that's on the facade, I'm going to right-click it, and I'm going to make it unique. Then I'm going to go in here, and you can kind of verify because when I select all these, they aren't selecting in that other one. And if I come back here and make another copy of this guy, and I double-click in, everything that I select in that one will highlight in the other, so that tells me that they're linked together. So if I come back to this one and make a change to the overall width, I guess I'll go back to my 155, then that one is forever kind of disassociated with those, and I can adjust them independently of each other. See here. I think that was all I was going to show. There are certain types of inputs that FormIT will take, or rather Dynamo Reach will take, and then FormIT will use. So you can see on the right here, I've got number sliders, and I've also got my favorite Boolean operations, or rather Boolean choices. So I've got the choice of a true and false on a couple of these, and I really like what Dynamo allows in this regard, because I can design this to use different logic paths depending on what I want. So you'll notice that one of my options I have is vertical equals true, horizontal equals false. So I have coded a specific path of logic for this, so that when I hit false, I can actually turn those louvers horizontal without doing any work. And it keeps the overall width and height and just changes that array to be horizontal. So that's pretty useful. And I use that in the storefront system scripts to add a door or not. And I use it in a couple of other instances to choose whether I want glass or whether I want a certain amount of options. In this case, I can center the louvers or flip them. So that's really nice. We also accept strings and integer sliders, things like that, and more in the future, which is pretty exciting. So there's a lot here and a lot that'll happen soon. And so that's what I was going to show, I think. Am I missing anything? Okay. Awesome. Oh yeah, do you guys have any questions?
Yeah, if you were going to punch a hole in the louvers, just for a window or something, how would you go about doing that?
So that's what's interesting. Yeah, if I wanted to make changes to the geometry that's inside here, I technically can. So as I pointed out before, you can hover over these faces and edges and you'll get the highlights. So if I select something, I can actually just delete one of the louvers, or I can delete a whole bunch of them. And that's totally valid to the degree that what you see is what you get. But if I wanted to change the parameters, all this stuff should be rebuilt. So we actually recommend not doing this unless you're ready to kind of, tell yourself that the parametric editing of this is over, because unexpected results may happen. Like if you place something in here and then you change a parameter, it might wipe that out. Or if you apply a material to one of the faces and change a parameter, it might wipe that out because it has to regenerate everything in here. But yeah, you have the option once you're done adjusting things, then you can kind of destroy or otherwise alter what's inside of the group. And at that point, FormIT doesn't really care. It's just once you want to change a parameter again, you'll probably lose the changes you've made. Having said that, I mentioned that that adding a material might get lost. So our trick for that is if I have a material that I want to apply to this and I want it to stay, I can apply that material on the group level. So in other words, I can apply it from the outside, and that will stay after I change parameters. But if I were to apply it to one of these louvers, it's sort of no promises whether things are going to be kept, because Dynamo will regenerate all of the faces and edges inside this group once you make a change to the parameters. Does that make sense?
Yes, thank you.
Yeah. Other questions before I hand it back to Tobias?
Anybody have a question? Well, this is awesome. Thank you, guys.
Of course.
For sharing.
All right, I'm going to bring the phone back to Tobias. Thanks, guys.
All right.
That's really cool. Thanks for hanging with us while we had some technical difficulties. I'm sorry.
No worries. It's a default on presentations when it comes to technology.
Exactly.
So we're going to be having Ihan presenting a rather less difficulties incorporated presentation on C# and Dynamo. So she's been working with Because We Can for I guess 2 years, and she's been working on creating rational and rationalization data design workflows and installations using Dynamo. So please welcome Ihan.
Try to keep it short.
I'll make you the first one.
this is briefly what I'm going to talk about today and look through it. I'm going to start with when not to use C#. And basically, if you can do anything else but go into C# land, you should definitely do it. If you're better at Python and you're dealing with just a lot of data that you're computing, stay away from C#. If you can make custom nodes within Dynamo or use Dynamo script, totally go there. So like, I think you guys are going to do that like 6-hour intensive on how to use Dynamo script. And what's great about it is it gives you inline editing. You can work in the window in Dynamo versus having to work in a whole entire separate environment. So like that's an example, my really bad example, but an example of how you can make kind of custom nodes using Dynamo script. And it's pretty easy and straightforward. And then next is Python, which is actually a lot better and more efficient at doing a lot of things in comparison to C#. But what it can do is basically C# lets you play with geometry in ways that are basically break what Dynamo has to offer as far as modeling goes. So it's good for creating interdependent objects, indexing your information in a way where you can link from one thing to another in a more intelligent way versus just a giant list of things that you have to filter through. So those are some of the things you can think about. And then bad parts about it is you have to compile it. It gets tricky. There's garbage collection, so I don't know if anyone's familiar with what that is, but basically every time you create an object that's a geometric object in Dynamo, if you're using C#, you have to delete it yourself, otherwise you're going to crash the whole entire system. So that's another downside of using C# is when you build your geometric objects, you have to be more careful about how you manage your objects. Right. So, but other parts are there's a lot of fun things you can do when you're creating your own geometry. So it's like this wasn't using C# but Java, which is very similar programming language, and this was slow. So that was actually, I guess, the coolest thing I've done generatively using code, using basically a whole entire mesh, building your own mesh network that you can crawl over and creating functions that allow basically a cube to grow organically into a tower, putting holes in and having like roots come out of it, using built-in random algorithms as well as flocking algorithms and other fun coding things out there. So it's basically how it would work. And the other side of it is like rationalization of objects. So this is more the conceptual phase of what is possible to do with coding, and this is more on the fabrication end. When you have a crazy design, how to build it, and basically you can create some crazy mesh form in any other program, and then using intelligent parameters to figure out how each piece can go together, you can then have it be built or rationalized to something that's actually achievable, which on building scale is slightly different. Then what that looks like is, so this is using a custom library. Control panels, you can color code fabrication, which ones you need, and you can highlight specific objects. If you're looking for a particular part with its labels and what it looks like, you can search through the objects, and you can ask it, like, find what's next to it, what row it's in, as well as other information that's embedded in the geometric object yourself. And the environment that you would work in is, so this is, if you actually want to start using C#, Visual Studio is the development environment that you would use. How to set it up is all available on the Dynamo Primer and on their GitHub that's available. And basically everything that was used to create those panels was all coded hard in these classes. The nice thing is once you create a class, you can create properties within them. So for meshes, the basis is, I don't know if anyone knows of half-edge mesh topology, but essentially every single point knows, like every single vertex knows what edge it's connected to, every edge would know what surface it's connected to, and every surface knows what its neighbors are. So in a building, being able to build something that has that kind of information embedded in the geometric object can be useful at times. And if those are some of the attributes that you're looking for in your nodes, then that would be a worthwhile time to jump over and use C#. It reads it directly. It compiles into a DLL file. So it's a zero-touch node on so if you go into this website, it actually explains how it is. But basically, using C#, you compile a DLL file that you can drop either into the core folder where Dynamo lives, and it'll automatically upload, or you can import it in Dynamo. When you say add library, you can look up the DLL you've compiled and be like, use this, and then it'll automatically load into Dynamo. So you're actually not messing with any of the APIs or any of the Dynamo core. You're just adding additional nodes. So it's kind of a nice, convenient way to like toss the same DLL. Yeah.
Things to test what you're...
Do it usually on the machine, and then you can publish it using Dynamo's publishing tool as a public library for everyone to use. Or you can keep all the betas, your test things in file with like the date on it. Or for each project, if you want to tweak a certain node from what you've already built, you can do that and name it something different, keep it in the same project folder as your Dynamo script, and it'll read it from that DLL each time you open the Dynamo script. So it's pretty convenient in certain ways, and zero-touch plugin development is what it is. And they have a giant robot that says danger. Basically anything that is visualized or tessellated will crash your computer eventually unless you manage it in the C# environment. So every time you create a surface, if you don't say surface, like I'm done with you, go into the garbage, your computer will remember every single thing you've generated until it runs out of memory and crashes. So that is the biggest dangers of it. And that's it. That's the quick and dirty intro to C# and what it can do. And
when did you start using C#?
C#, I started with Java. C#, I've probably only been using it for 3 years, but did like a couple of years of Java before that, so it is helpful to know coding, but if you are into coding or want to do some of the things, it's worth investing your time. Because the only way you can get better at coding, it doesn't matter what language, is just do it a bunch of times.
Yeah.
And there is really no right way to do it. There are less bad ways.
Yeah.
But it's more about trial and error and going through the documentation, as boring as it is. But if you have a clear idea of where you want to start and what you want as an output, it's really easy to find online how to get to that final point of what output you want. But if you're kind of looking around and looking for inspiration, it's probably not the best place to start.
I didn't quite understand that part at the beginning about why C# is more powerful than Python in some cases, about extending like the geometric capabilities. What is it that C# can do that Python can't?
It does a better job of having properties, so additional information. Like you can create a class. It's actually not technically more powerful, but in combination with Dynamo, it's more powerful because you're kind of limited to manipulating data only, strings, numbers, and minor geometric things using Dynamo's built-in platform. But with C# you can create classes where you could have multiple layers of geometric information embodied in one object. So you can layer things in a way that's not possible. Basically, if you think of Python, lets you go from like one point to another point, and the class basically lets you kind of do a loop where you can go one way and back in one object.
Okay.
So that's the best way to explain it, I think.
What's the name of that geometric type that organized points and edges and surfaces and neighbors?
Mm-hmm.
What was the name of that?
Topology.
Half-edge mesh.
Oh, half-edge mesh. There's kind of two schools of thoughts on how meshes are organized. And basically, one is at the end of the day, you have a bunch of half edges, and you can detect like outside edges that way. So if you have more than each edge is composed of two half edges, and if you have an edge that only has one, that means it's in the open, it's not touching anything. And it gives you a direction as well on how to move, so you know where inside and outside is at the same time.
So you're an architect and a mathematician, right?
Yes.
So
I do have a math.
you self-taught programming?
Somewhat. In grad school, everyone gets a chance, or some people get a chance to play with processing. So I started with processing and thought it wasn't strong enough or powerful enough. So then I went to Java, which is really close. And then I just kind of did it long enough and taught myself C#. And the documentation, as long as the language is well documented, you pretty much know the limitations of what the software or the language has to offer. And the rest is your imagination, your creativity, or dedication to solve a problem using those tools. But it's all documented. Just kind of a matter of tracking down how to use each one in a methodological way.
Do you use Microsoft libraries for your work? Or?
I actually generally create libraries or geometric objects from scratch, and it ends up being a lot of vector math. So like with meshes, if anyone's trying to actually build a closed mesh with like really nice seams, you know that the second you make it thicker, it disrupts the mesh. So calculating all the angles between the surfaces and the corners and figuring out how to, like what clearance angle is required so that when you cut all those pieces, it assembles and looks exactly like the single abstract mesh that you started with.
So what are you saying? Are you saying
Some
that
of
you
it's
don't use
course.
it? You don't use any of it. You just sort of do it.
I use their geometric library, some of it,
Okay.
but only to bake it. Dynamo was still underdeveloped when I started doing it, so I ended up building everything from scratch as far as the mesh library is concerned. I think they're supposed to integrate Mesh Toolkit, which Autodesk acquired, which deals with meshes in a more intelligent way, but I don't think they've fully integrated yet because it's not as useful to most people.
Okay, well, maybe you'd be interested in this. I guess you guys call it the Dynamo script now. It used to be called Design Script, right? And where it was left off, they decided to sort of integrate it with Dynamo. So now there's this site called designscript.io, which I guess Robert Ashe, who was the Autodesk guy that he left there. Now he's in England, and he, that's like a new library. It's a new description of how of just pure design script. Okay, so they've got a grant now to do some work in non-manifold topology, which is where they kind of left off on design script.
Right.
I mean, that's why I think that they sort of separated with, because he had still a long way to go to the team to get the whole thing. You probably know a lot more about it than I do, but generally, they just got this grant. Him, Robert Ashe, who's at the Bartlett now in the School of Architecture in London.
Yes.
And then this Washbi Jabi, who's at University of, let's see, I think he's with the Wells School of Architecture, right? Cardiff University. So they got a grant to, do this more work on non-manifold topology. So, you need C# for all that. So.
You need C# for all of that.
So.
Or basically the idea of intelligent geometry, like knowing what it's next to, you need C# for that. But if you're brute forcing geometry, then it's not as useful. You can just do it in Python or the custom nodes here.
So anyway, I mean, just for your interest,
yes,
you might want to look at that. I mean, I don't know how. I don't think it's that widely known that it's out there. Yeah, and
Are they
in the next year or so, they'll probably start, putting out this information. It's all going to be, I'm sure it can integrate with whatever. I mean, it's supposed to be free and the same kind of thing that, But is that right? It's called a Dynamo script now? Design script? Yeah.
Or design script. But yeah, if the screen updates, you can basically the panel system of how to make it. If you look at it, it has a bunch of parameters you can change based on that mesh, and you can essentially, it goes all the way out to, these are all custom nodes based on the system of how to make a mesh buildable, down to exporting an SAT to re-import into Rhino for blocking out, to making, you can actually, I was currently working on having Dynamo actually put out G-code directly, so you can actually have a file that you can send to a CNC straight out of Dynamo and be like, hey, cut this for me, and it'll know what to do. So those are kind of more the fabrication side of what is possible. And this is more rationalization. But it looks prettier than having a bunch of nodes that cover, a giant page as well, aesthetically.
I guess that's the limitation of Dynamo or script language, is that it gets so massive, and you really need to sort of redefine, I think that's another area that, is sort of...
let's say that this one little node does a lot of heavy lifting. It basically takes the input mesh, rationalizes, reorganizes, and labels every single face, edge, dot, and it does it really quickly because I'm not using their built-in mesh thing, and allows, like, it's slow in building the forms at the end, but it's basically allows me to do nonlinear analysis of an input and designate important and unimportant information that can be extracted from that mesh and filtered out to one thing that outputs a result that can then be, like, broken down the way Grasshopper and Dynamo is used to doing. But if you're trying to analyze a trapezoidal solid, like, try to imagine building something that's essentially extrusion with a pyramid on top of it, just in Dynamo, period. Like, if you try to think of it, that would be a giant pain in the butt, and this kind of just automates all of that for you with just straight equations. So potentials for that, this is really boring, but if you had an elaborate pattern, say, that would refer to how the angle or any of the geometric information, you can then array it on any object you bring in to have that pattern, like, grown on it, is the potential of what C# allows you to do.
And what is your process to import this into Revit?
It used to be, before they got rid of the SAT import, was actually to bake an SAT file and then put it into a Revit family so that the solids all read as solids and you can apply materials and everything. And you can filter it. Like, if you make a node where you filter things for different materials, you can export it as different SATs that you then apply different materials to. So it renders really nicely for clients. I actually ended up writing my own DXF exporter because Dynamo has not allowed you to export DXFs still to this day, right? So those are, like, the little things. But the other nice thing about C# or Python is there's so much code out there, like, copy paste at will. Like, you can learn a lot just by going through someone else's code. Like, everything's already been invented. Like, all I did was import someone else's, or look at their C# code already existing for DXF writers and adjust it from 2D to 3D to, like, have it make DXFs, like, three-dimensional proper DXFs for me. So that's the other nice thing, is you can co-op everyone else's code that already exists out there as freeware. Just give them some credit, and that opens a lot more things so you don't have to do the complicated stuff, but the more fun stuff. This is published. Yeah, you
or does it
can.
have to go through the intermediary for that node to be formatted and labeled?
Nope. It's there's a certain form you have to do in C#. So anything that I've labeled them actually. So anything that's properties pops up as a query. So anything that's labeled as a get set. Like, if you make it in that form, Dynamo automatically recognizes it as a query object. So there's constructors. So this is usually where all the work happens. This is for simple math equations that I found handy. But if you look at it, so this is all. That's one line is a node that creates in Dynamo. As long as you create it as a public static, it's something that creates an object. But it's just calling an internal, the internal constructor, and that's what it's doing inside of it. You're telling it.
Translation into
Yeah. Mm-hmm. So you don't actually have to do any of that work unless you really want to. If you format your code in a particular way, you can download it off of their primer. It'll automatically recognize it as a create, an action, or a create. So it's you have to be aware of what you're doing, so you have to be organized about your code in a certain way. But and you can even comment these gray things that are, this actually pops up in that little window in Dynamo when you hover over the node.
How do you debug this? Like do you have to insert the DLL into the Dynamo and run it there, or could you try to compile it through the Revit add-in tool and see what
you can do it all in the it's Microsoft Visual Studio. It's free. If you try to build it and there's something wrong, it'll catch it. It's actually really nice to have a proper environment. It'll catch your errors. It'll tell you what's wrong. It'll give you suggestions. It'll auto-correct. It'll like actually show you what's available, like in Rhino, where you start typing and you get the whole entire list of what's possible.
But if you're going through zero touch and you have to compile a whole thing, load it into Dynamo, have it read it, and then see your output in some form of geometrical shape, do you compile it like in pieces then? Do you check just pieces of it and make sure that what you're asking for is what you're seeing, and then at the very end you just compile the whole thing?
That is one way to do it. If you're clever, you will isolate. If you see here, each one is a separate class of the different things that I've created over time. They're each long, really long pages. You can create, they have a relatively robust unit testing built in that's pretty easy to implement. So if you see all the way on the left here, those are all tests that I can run to make sure that those nodes or those operations run. So that I can make sure that things are going to function the way that they're supposed to before I import it. But yes, to actually play with the geometry and make sure that everything goes exactly the way you want it to, you do have to bring it at least into Dynamo Sandbox to make sure you get the results that you want. That's another downside, but it's worth it sometimes.
Did you also say that you were bringing in Java or
so
JavaScript?
You can do both ways. I just started this kind of queries in Java, so it translates pretty well in how to make classes, inheritance, and all that. Like the crazy thing that was generative was done in Java, but it can be also done in C#.
But could you build your Java and somehow import it?
Yes, okay. You can. It's not the most efficient way, but you can totally do that. You'd have to find an interpreter.
That's why I jumped from like Java to C#, because I couldn't find a way to get Java. You
can probably find a Java interpreter that will spit out equivalent C# code, but I wouldn't trust it per se. But if you wrote it in Java, you can probably copy paste most of it over and just fix a couple of things and it should function, more or less. And if you've ever used Eclipse, the Visual Studio works pretty similar. Layout's a little different. Any other questions on?
Can you explain one more time about that intelligent geometry mentioned? I don't know if I got it right or not, but it said in C# we can recognize if one object is next to the other object, right?
You can, yes. You have to build it that way. So basically what that is building in topology into an object. So this panel right here knows, because each one has to be labeled, it has to know each edge, and it knows every single panel it's next to it. So if you wanted to, you can paint a bullseye on this, starting from one, and it can do a successive ring that grows bigger around each one.
Can I ask how you define that? Like, did the coordinates of the edges and then find the span?
Basically, yes. And more or less, you can have any mesh and you kind of have to define how you want to organize it. But if you have a smart SAT, things have a normal, things have information embedded in it, and basically C# lets you interpret that and make it more accessible, or that information more accessible to you, so that you can be like, hey, panel, who's the panel next to you? And be like, oh, these 4 guys are next to me. And you can be like, oh, this point, like how many guys are stuck to you? And it can tell you 7 without doing any kind of search, just by drilling down. So if you look at the topology, it's the property of the class itself. So if you look at this vertex point, it has a hash set of edges. So it has a property built into it that has all the edges connected to it and all the faces connected to it. It's basically indexed within that geometric object. So you just kind of, when you iterate through the object, you basically put all those indices in place. So when it's all done, you can drill down and find it. So, does that help? I'm not quite sure if that's understandable.
So have you done this mainly just meshes?
Mainly with meshes. I mean, you could do it with other objects, but meshes are the easiest thing to do it at that level. I've built meshes from scratch 3 times. This is like the 4th iteration, so it's, I think, the cleanest version.
Are you using the G-code is bringing from the blocks for fabrication?
So,
G-code?
not as much, because there's certain things that fabrication, like CAD/CAM software, does. It's really convenient. So it's actually a lot easier to just get DXFs, like really clean DXFs out of it. That's all made out of arcs and lines in ways that make sense, and then rationalize it the last of the way using CAD/CAM software.
And correct me, some of these tools are available in the package, right?
Yes, everything here is open source. It's on GitHub because we Dynamo. So it's all there to copy paste for your use. So this is all open. So everything I've shown you is live and updated with testing, and it has all the classes. They don't work perfectly for all applications because they're designed with a very specific purpose in mind, but you can definitely steal the mesh basis and do whatever you would like to it. It's all available, including the DXF. There's occasionally an arc that messes up due to the latest update, but they're all there to copy paste into your own projects if you'd like.
Is the difference in capability between C# and Python just, it's not an inherent language difference,
No.
right? It's just how Dynamo can do
Yes.
important.
Yeah, it's mainly that. But there are certain things that make it, I don't know, I'm not a trained coder, but there's certain things that are nicer with, like white space matters. It's a lot harder to debug Python for complex classes. Inheritance isn't as straightforward. We can only inherit one thing versus multiple things. So as you get more complex, you find that C# is actually more favorable for class level, like creating objects versus Python. But yes, Python can do everything just as well.
So that's great. So thank you for that. Anybody have a question for Brian? You guys are based in Oakland, right? And I've seen the work of Because We Can. It's really great. Fabrication shop. They have open houses.
Occasionally.
So.
Once a season, normally. There's robot arms that you can control with Xbox controllers that are kind of fun to play with. So, A little bit. That uses C# as well. They came with the Xbox controller, but working on animating the robot arms using Blender so that can use a bunch of freeware to have the robot arms actually cut using a router, like a 3D object. But that's a lot more complicated math than I have time for. That's like a hobby for the company, not really.
Almost want me to start creating a C# user group.
There you go.
Oh, thank you. And if you guys like more of these type of topics, I'm happy to reach out, or if you have friends that want to contribute to the group, maybe digestible chunks, we could put that down the line. Or what?
Yeah, we could do a C# workshop.
I mean,
Why not?
Yeah.
Some of this that we don't always have the time to get into, and it's usually a group of people who bounce ideas off of, because I know nobody else is trying to dive into that. I have no idea where to start.
I went to a Python class, I think at Galvanize, but it was geared to, it has different purpose. It's for data science.
Right.
It's not.
That's
it's very hard to find a course or resources that are focused to detect problems that we face.
Yeah. It's true.
A lot is there's a big vacuum there. Oh yeah, so Conrad so long. It will be presenting in May. So in a related topic. It's connected from New York. And then Brian Ringley from here, from Bagot, will be the June presenter. We'll come back to this.
Sorry, I should stop sharing my screen.
Better said. Yeah, combination of so many things.
All right.
Well, thank you everyone for coming.
I got a photo of the user machine that's phone because mine ran out of storage right at the last second. So I asked her to send it to you, and I'll remind her tomorrow. But if I forget, remind me and I'll remind her, or you can remind her. Still, kind of such tweets that are